This is an example of a pedigree that can just scare you to death when you see it because it's so big. There's so many individuals in this pedigree that it has the potential of intimidating you. Let me just encourage you to pay attention to the pedigree, to focus on the idea of X-linked recessive traits. Now, this particular pedigree is showing the inheritance pattern of an X-linked recessive trait called hemophilia. And perhaps you've heard of the term hemophiliac as an individual that has a genetic disorder that results in an inability for the blood to clot appropriately. Hemophilia is an X-linked inherited disorder. And we're going to talk about hemophilia in more detail when we look at one of the chapters in Abraham Lincoln's DNA, talking about royal families and the inheritance of traits through royal families. Because pedigree records were kept in such detail of royal families and the marriages and intermarriages between different families, they represent a tremendous genetic resource for understanding more information about modes of inheritance. Now, the benefit in this particular pedigree is they've indicated to you which individuals were carriers. Remember, only females can be carriers for the trait because they have two X chromosomes present in them. Now, I just noticed this, a female named Eugene. Whoa, that's scary. So maybe a mistake in the pedigree symbolism, or pedigree name here, I'm not sure. So we'll ignore that and stick with the symbols as being the reliable feature to go on. Now, in this particular pedigree, Queen Victoria experienced a spontaneous mutation. And that spontaneous mutation was one that resulted in hemophilia. So she had children with a phenotypically normal man, which meant she was a heterozygote, and the phenotypic normal individual, Prince Albert, had a dominant allele on his X chromosome. Now, if she had one X that was affected and the other X was normal, we would expect half of her sons to be affected and half of her sons to be unaffected. Because remember, sons get their Y chromosome from the father, they get their X from the mom. So if we look at her sons that were produced, we can see Edward VII was normal, we can see Alfred was normal, we can see Arthur was normal, and we can see Leopold was affected. Now you might say, well, wait a minute, that's not half. Remember, you can flip a coin 4 times and get heads every time. It may not be probable, but it can happen. So in this particular case, Leopold was affected. That meant that he had the recessive allele on his X chromosome. So Leopold had children with an unnamed female, and he produced a son and a daughter. Now, if the female was not a carrier, all of the sons produced would be normal. Because remember, they get the X chromosome from mom. However, daughters get one X from their father. The father is hemizygous for the recessive allele, so he only has one X to give, which would mean we would expect all of his daughters, in this case simply one shown, to be at least the carrier. Now, if the mother had been a carrier, then it would be possible to produce a daughter that was affected, but with a normal mom and an affected dad, all of the daughters will be carriers. Okay? Now, in this particular case, we had a female who was a carrier and a male who was normal. So again, we would expect half of the females to be carriers because they could either get the normal X from mom or they could get the recessive X from mom. And in this case, this individual received the recessive X, while we look at the sons and we see some sons that are affected and one son that's unaffected. Again, that makes sense because they get the Y chromosome from father. The mother is a carrier, so we would expect half of her sons to be affected, half of her sons to be unaffected. And so if we follow this pathway down, we can apply the same thinking to these other lines of inheritance within the pedigree. So for example, in this particular case, we have a female who's affected, a normal male. They had 3 sons. We would expect half of the sons to be affected, half of the sons to be unaffected. Let me ask you a question. If they had produced a daughter, what would have been the probability of the daughter being a carrier? And your answer should have been 1/2, because they could either get the normal X from mom or they could get the affected X from mom. So this is an example of how you apply X-linked recessive inheritance to a very complicated pedigree.